Okay, we're recording, and I haven't done this for a while, so hopefully this will come out decently. Okay, question number 1, and let's see if I can actually do this, if I remember how to. 38 girls, 25 boys in a gym class. Write the ratio of girls to students in the class. So careful here. So number 1, you want the ratio, and there we go, ratio of girls and to the total number of students in this class, okay, to total. So it's a part to total ratio, okay. The ratio of girls, the number of girls are given to you, which is 38, but you're not given the total. And in this case, you have to find the total. Obviously, you add the number of girls and you add the number of boys, which is 38, plus 25. And you get a total of 38 over, if I'm not mistaken, 63. 38 is the number of girls, and 65 is the total. Okay, so that was question number 1. Very careful. If you did 38 over 25, that's incorrect because it's not asking for the ratio of girls to boys. Okay. Wow, this feels weird. Not doing this for so long. Number 2. Apple juice comes in 3 sizes. Okay, size A, size B, and size C. So here you need to find the unit rate for each one. Okay, and we'll take this. So size A. So write the rate as a fraction. It always helps. And because it's money, I like to have money on top. Okay, you don't have to, but it's usually easier. It's $40 for 40 ounces. Okay, let's just take care of this right away. And to find a unit rate, you divide top and bottom here by 40. And that will give you 1 ounce at the bottom. Forget, there's a little delay here. 1 ounce, and then 10 divided by 40, that should give you, I believe, 20 cents. Sorry, 25 cents. Okay, so 1 ounce for size A is 25 cents. Okay, let's move the screen down just a little bit. And we'll do size B over here. Size B says $6, and you get 25 ounces. Alright, so again you have to find, let me just write ounces. Get the unit rate here, because you want the price per ounce. So that's divide by 25, divide by 25, and you get that 1 ounce, in this case, ends up being 24 cents. Okay. And finally we have size C. And you have, this one cost you $14, and you get 70 ounces. And then we're going to divide top by 70 and bottom by 70, and that's going to give you about, if I'm not mistaken, 20 cents per ounce for 1 ounce. Okay, now that you have the price of all these 3 sizes as a rate per ounce, you can easily tell that the cheapest one is this guy right here, size C. Okay, well, talk about delay. Size C, so because it's 20 cents per ounce, so the better deal or the best deal here is size C, because it's 5 cents cheaper than size A and 4 cents cheaper than size B. Okay. Número 3. Well, why is this? Alright, I'm gonna have to eventually fix the delay here. Number 3, cafeteria measures 72 yards in length. Tina has a measuring stick that measures 4 feet. How many of those sticks does Tina need to measure? Does Tina need to measure the whole length of the cafeteria? So let's figure out what. Here we have a little issue. Whole cafeteria is 72 yards. That's a big cafeteria, by the way. And she has a stick that measures 4 feet. Our first problem is that you're dealing with yards and feet. So let's change everything to feet. Okay? Since the stick is in feet, let's figure out how many 72, how many yards, how many feet 72 yards equals to. So 1 yard is 3 feet. And multiply that. and you get 5 over here, not, sorry, 6. Let's change it to 6. And 3 times 7 is 21, so you get that it's 216 feet. Okay, so to measure that whole length using a measuring stick that's 4 feet long, easily you divide 216 divided by 4, and you end up getting a total of 54 sticks. Okay, so if you can imagine, and then obviously imagine a cafeteria that is invisible right now, and it should be catching up. Wow, I'm really wondering why the delay here. Huh. Well, there you go. So there's your cafeteria, and you have a stick here that measures 4 feet. Okay, and you're going to use that stick to measure the whole length. That'd be one little stick. Get another one. Get another one. And you put one in front of the other. Okay, to measure the whole cafeteria, you would need, as we said, 54 of those 4 feet sticks to measure the whole cafeteria. Okay. Numero 4. Numero 4. Write 3 ratios that are equivalent to 18 over 30 or 18 to 30. Okay. Let's write that as a fraction. A little easier. So you can go either way. You can go higher. You can go lower. Divide top and bottom by 2. You got 9 over 15. Divide top and bottom by 3. You get 3 over 5. If you wanted to go higher, you could have done 36 over 60. Okay. Did I ask for 3? Yeah, 3 ratios. That's enough. Okay. As long as you multiply or divide top and bottom by the same number, you know that you just created an equivalent ratio. Okay. Now we have a table. That was number 4. Sorry, and this is number 5 coming up. Well, doesn't look like a, wait, there we go, 5. We have a table, very easy table. Okay, cars and buses. Okay, 18, 25, 75, 108, 125. Okay, and the 125 should appear. Good. All right, so remember, equivalent ratios. So 18 over 25, and you want to find the numerator here on top of 75. Find a relationship. In this case, times 3. And obviously, it's going to be the same thing on top, times 3, giving you 54. I'm going to change colors here, or not. Okay, and then to 108. To 108, there we go. It's times times 6. Okay, and the bottom is times 6 as well. And you get 150. Let me change color one more time. And 25 to 125, it's going to be times 5, which makes that other 18 times 5, and that gives you 90. Okay? I'll really work on this lag here. I don't know why this is such a delay. So that's 5, not too many more. Let's see. It's 5. Number 6. Let's go back to our initial color here. Number 6, the bookstore has 30 magazines, 50 books, 28 newspapers. What is the ratio of books to total number of reading material? So you want the ratio of books, and again to total. Total and books, you're missing an O over here. Good. The total number of books is 15. And you want to find, it is again, it's a part to total, so the total number of reading materials would be the combined sum of 30 plus the 15 plus the 28, giving you a total at the bottom of 73, and the total number on top was 15 books. So you have 15 books out of a total of 73 reading materials. Okay. Number 7. Lisa drives 54 miles in 2 hours. How many miles can she drive in 8 hours? You're free to choose whatever method you're comfortable with. Let's stick to proportions. So you can write 54 miles. 54 miles in 2 hours. And on the other side, you're going to write, what are we interested in? And oh, how many hours should I? 8 hours. So 8 hours goes at the bottom. And we're interested in miles on top. Easy relationship. 2 to 8 is times 4. And on top it's going to be the same, times 4. And you get 216 miles. Okay, I'm going to change color here. And wait for it to show up. Okay, here we go. And now 9 hours. Well, for 9 hours, 54 miles and 2 hours. And this time around you want 9 hours. Okay. There is a relationship. I think it's pretty obvious that from 2 to 9 is times 4.5. And you could have done the same on top, times 4.5. Okay, but if you didn't want to do that, okay, you could have simplified. Okay, and I'll just show you. You could have simplified, meaning instead of 54 miles in 2 hours, oops, too much. Instead of 54 miles in 2 hours, you can simplify that. Divide top and bottom by 2 and write 27 miles in 1 hour. Okay, and set up your proportion again. And now you'll see that there is a direct relationship, a very much easier relationship. From 1 to 9, obviously, it's times 9. And then obviously you're going to apply that same. It's going to be times 9 on top. 9 times 7 is 63. Carry the 6. 18 plus 6, 243. 243 miles. Okay? You can fast forward if you the video is too slow and you're comfortable with the questions. Number 8. Try another page. Number 8. A football team has 24 players. 7 of them are girls. You want a part-to-part ratio. Part-to-part ratio. If you went ahead and did 7 girls and 24 players, that's incorrect, because the 7 girls are definitely part of the team, but the 24 players here, it's the total number of players. So if you did 7 to 24, that is the incorrect ratio. You want a part-to-part. Well, from the information given to you, you know there are 24 players. And from the 24 players, if 7 of them are girls, the rest of them must be boys, making it 17. Okay, so now that you know how many boys there are, you can write a part-to-part ratio. You can either say 7 girls to 17 boys. Did I write boy? Oof, that was ugly. 7 girls, 17 boys, or 17 boys to 7 girls. Either one, they're both part to part. Okay, but you definitely needed to figure out that if there were 24 players and 7 of them are girls, the remaining part of the team would be 17 boys. Okay. Types of songs. The following shows the types of songs in Mr. Cho's playlist: 60 rock, classical 150, and jazz 200. So, and you want to compare the number of rock songs to jazz songs in simplest form. So there are 60 rock songs. Okay, and I'm going to write as a fraction to 200 jazz songs. So you're comparing 600 rock songs, 200 jazz songs. Okay, and here's your comparison. Here's your ratio of rock to jazz, and you want to simplify that. In simplest form, let's say you can divide top by 20, bottom by 20, and you get 60 divided by 20 is 3, and 200 divided by 20 is 10. Okay, so 60 rock songs over 200 jazz songs simplifies to 3 rock, 10 jazz. They mean exactly the same thing. Okay, if you didn't divide by 20 and divide it, you could have divided by, I don't know, 2 first and then by 10 later, or however. You know, you don't have to take one step to go from here to here. If you took 2 steps or 3 steps, it's completely fine. Okay, number 10. So that was number 9. Sorry, I'm writing the question number. So number 10. Ooh, it's a GCF question, and that is, so GCF question is on your test. So GCF here says there are 48 pencils, 64 pens. Tarzan, wow, Tarzan, wants to give them out to as many friends as possible. What is the greater number of gift bags that he can buy so that every bag has the same amount of pens, same amount of pencils? So, okay, let's go down memory lane here. Easiest way to find GCF here is to use a ladder method here, or a slide method, however you want to call this. Okay, hopefully you remember this. 48, 64, 2 goes into 48, 24 times, 32 over here. Okay, we can still simplify. That's a 12, and that's a 16, and that's going to be a 2 again, giving us a 6 and a 8. Am I doing something wrong here? 2, 4, 8. And we're going to do a 2 again here, and a 3 and a 4. Okay, so remember the GCF are numbers on the side, the product of the numbers on the side, so you get 2 times 2 times 2 times 2, which this is going to give you a 2, 4, 8, 16. Okay, so Tarzan here can buy 16 gift bags, or 16 bags. 16 bags, okay, bags, and in each bag he's going to have 3 pencils and 4 pens, and those are the numbers down here. Okay, which reminds me that on number 10 I made a mistake on the picture. It should have been 12. It should have been 16 instead of 8. Okay, so you'll probably catch that error on the picture. Okay. Number 11. Use the distributive property to write an equivalent expression for 18 plus 24. Here is your expression, 18 plus 24. Okay, so remember, distributive property. So you want to come up with a format like this. And this one has, so you can think of a number, okay, that goes into 18 and 24. In this case, let's start with an easy one, 2. So think of the numbers inside the parentheses. So 2 times what will give you 18? 2 times 9. And 2 times what would give you 24? 2 times 12. So remember, distributive property, you're multiplying the number outside here with each term inside. So 2 times 9 is 18, and 2 times 12 is 24. So this would be a possibility. Try thinking of others. 18 and 24 share 3 too. So 3 times 6 is 18 plus 3 times 8. So this is a possibility. I think 6 is a possibility too. So 6 times 3 is 18 and 6 times 4 is 24. And we have one more, and the obvious 1. 1 times 18 is 18 and 1 times 24 is 24. All these are perfectly fine answers. Okay. They're all equivalent to 18 plus 24, but if the question asks you for the one that uses the greatest common factor, you want to talk about this one right here, the one that has a 6. Okay, 6 is the greatest number that 18 and 24 share. Okay, and then we have next one. Complete the table below, miles and hours. Okay, so the screen stops moving. Okay, stop. So here we have 40, or not, 40, 120, 50, 65, and 90, and you're asked to complete the table. So, okay, so if you looked at the picture that I posted, it's done. I did it in 2 ways. Okay, I'd like you to do it. Well, you can choose, but the one way we've been doing it in class is to obviously there's no a relationship between 40 and 50 or 40 and 65 or even 40 and 90. Nothing you multiply, nothing multiplied by 40 will give you 65. Unless it's a decimal, but you don't need to figure out what the decimal is. So the easiest way is to somehow change this guy here. Okay, 40 over 20. And one way of doing it is to create another equivalent ratio. So 40 and 120, if you can, change it this way. Divide top by 40, divide bottom by 40. And this one, if you get 40 divided by 40, you get 1 here, and 120 divided by 40, you get 30. Look how pretty that is. Now, you can find a very easy relation from 1 to 50, which is times 50. Therefore, sorry, this is not a 30. It should have been a 3. 1 over 3. So 3. Anyways, 1 times 50 is 50, so 3 times 50 would give you 150. And next would be 1 to go to 65, and it's 1 times 65. And you'll multiply 3 times 65. 3 times 65 is 15, 195. And finally the 1 to go to 90 is times 90. And the 3 will be times 90 as well, which is 270. Okay. And the easy way, which I'm pretty sure I didn't show you, because I like you guys to think about equivalent ratios. Okay, so another way of doing this is find a relationship up and down this way. That relationship tells you that 40, it's times 3. 42 become 120 is times 3. So you're going to do the same thing here. Same thing here. And the same thing here. Notice that you're going to get the same answer that we got on top. Okay? I like the other method. This one is easier, but the other one works with forces you to think about equivalent ratios. Okay, and then we have the last problem. And the last problem, okay, 30 miles, you have a rate that says 30 miles in 2 hours. You want to create a double number line, a table, and a graph. Okay, so let's start with the table. 30 miles, 2 hours. Okay, let me write M over here. So we create a table. We want to find out how much number of miles in 14 hours. Okay, so you can go 4, 6, 8, 10, 12, 14. Okay. And same thing on the other side, left side, you go 60. You skip counting by 30s. 30, 60, 90, 120, 150, 180, 210. And there's your answer right here. Okay. And I'm just going to go ahead. If you wanted to do a double number line, okay, maybe I should wait until the color shows up. Why is this so slow? Okay. Shut some of these up. Let's quit. Quit. Yeah, that's about it. So there's your double number line. And again, same thing. Okay, so here's my 0, 0. Let's call the top one miles. M for miles, H for hours. And it's pretty much the same thing as a table, except that it's on a number line. So miles, we'll start 30, 60, 90, 120, 150, 180, 210, and we'll even go one more, 240. Okay, make sure that the bottom line lines up right under the corresponding one on top. Okay, and this one we have hours, so we'll skip counting by 2, 4, 6, 8, 12, 10, oops, wait, 2, 4, 6, 8, 10, 12, 4, 6, 8, 10, 12, 14, and 16. The one we're interested in is 14, and in 14 hours, 180 miles are driven. Okay. Now comes the hard part, which is the graph, considering what I have to work with and the lag this is creating. So let's try. Okay, let's try. So here we go. Here's a line. Oops. Forgive me, guys. I don't know why this is so bad. Alright, anyways. So, I'm going to try to make one as best as I can. We have our table, so we can use the information on the table that we just created. And if I'm not mistaken, this is hours. These are going to be my miles. It's going to be my x-axis. This is going to be my y-axis. My title is going to be miles per hour because we don't have a story here, so let's just make it miles per hour. And let's call this hours. So now it's got 2, 4, 6, 8, 10, 12, 14. You got on the mile side we have 30, 60, 90, 120, 150, 180, 210. I think that's as far as we have to go. Yes, we do. Miles. So 2, 4, 6, 8, 10, 12, 14 hours. Usually goes on your x-axis, okay? Here's 30, 60, 90, 120, 150, 180, 210. Changing colors. Okay, and if you are going to be doing this on the test, you're definitely getting little graph there. So don't worry, you're not gonna have to do something like this, like I'm doing. Okay. Thank goodness it's the last question, because I think the more we go, the slower this is getting. So I'm just gonna have to figure out why I'm having so many issues. Okay, so your answer is going to be a point over here, 14 hours and 210. So that coordinate point is actually called 14. Uh-oh. Something's not working. Alright, so while we're waiting, here's something that I used to do for those who would watch the videos. Come Monday, if you wear a mismatched sock, meaning your left sock and your right sock are completely different, you get 2 extra points on that test. Percentage points, let me be clear. Okay? So, make it a little thank you for watching the video and enduring this horrible delay. So, I'm gonna try to do this as neatly as I can. There you go. So, that would be a complete table, and this point right here would be point 14 on the x-axis and 210 on the y-axis. Okay, so remember, mix match socks, get to 2 points. Hopefully this helps you. If you have any questions, email me. Okay, and we'll end the video now. If I can find the stop button.